Hello everyone. So today I want to kick off the first unit and chapter 14, and we're going to be talking about trig identities. Now this section is essentially like solving little puzzles. And to solve these puzzles, you need to be familiar with the main trig identities. These are all listed in your textbook, but I've written the most important ones right here. So for example, sine, we know sine already. Well, sine is going to be 1 over what's known as cosecant. They're like an inverse relationship, reciprocal trig identity right there, okay? Same kind of deal with cosine. Cosine is going to be equal to 1 over secant, which is the reciprocal identity for cosine, okay? Now, there's some other ones listed in your textbook, but mainly they're just manipulations of the ones I have right here. Also, be aware of the tangent ones. Tangent is going to be equal to sine over cosine. The cotangent is reciprocal identity of tangent, and so it's just the reciprocal of it. It's cosine over sine. And then you have what's known as the Pythagorean identities. Okay, and you just need to be able to know these and be able to manipulate with them. So the first one is cosine squared plus sine squared equals 1. Then you have 1 plus tangent squared equals secant squared. And then we got 1 plus cotangent squared equals cosecant squared. Okay, so the problems we're going to be doing in this section is basically you're trying to simplify things or make one side look like another side. Okay, so my big tip to do these problems, and I'll walk you through some examples. It doesn't always work this way, but in general, convert everything to sine and cosine first, okay? Sometimes you won't need to do that, particularly when you're dealing with something direct, when you can directly use one of these Pythagorean identities. You won't do that. But often, if you're stuck, try turning everything into sine and cosine. Okay, if you see squares of stuff, that means you're going to be doing a Pythagorean identity. But let's practice this a little bit. Okay, let's start off with number 7. So number 7 asks you to verify each identity. Okay, don't worry about the domain question for right now. Okay, for this homework assignment, all I want you to do is be able to verify the identity. Well, what does verify mean? That just means you need to get one side of the equation equal to the other side, okay? And so let's look at number 7. So I have cosine of theta equals cotangent of theta is equal to 1 over sine theta minus sine theta. Okay, so this is actually a complicated one. For first problem, they gave you a difficult one. So my tip, let's do my tip. Convert everything to sine and cosine first. Well, cotangent is not currently in sine and cosine, but I have this handy identity here that lets me do that. So let me write that out then. So I'm going to rewrite it. So I got cosine of theta is times cosine over sine of theta. And I still have these other guys here. Minus sine of theta. All right, so what I want to do now is, well, I'm going to get my cosines on one side, and let's get my sines on the other side. I don't like that 1 over sine. So what I'm going to do is multiply both sides by sine of theta. So what I'm left with is cosine theta times cosine of theta times sine, and we have the rest of the stuff here. It's like that. And now we just combine things. Cosine times cosine is cosine squared of theta, written like this. Multiplying through, sine times 1 over sine is 1. Sine times sine is sine squared. Okay, notice we have squares now. Okay, squares are a hint we want to use a Pythagorean identity. And the one we want to use is this guy right here. Okay? What's that saying? Well, it's saying cosine squared plus sine squared is equal to 1. Well, if I want to, I don't need to do this, but I'll show you. You could actually kind of skip this step. But what I'm going to do is I'm going to move that sign over just so it looks all perfect. So I'm going to add sine squared to both sides. Oops, I'll do that. Cosine squared is equal to 1. And now I can just use my identity. 1 is equal to 1. Okay, and that's done at this point. And check. Now, I didn't need to do that, however, I could do something more direct. Okay, you're allowed to manipulate this right here. I know that using the same identity, 1 minus sine squared, I know that's equal to, if I look at the identity right here, 1 minus sine squared, if I subtract the sine squared and move it to the right-hand side, is going to be equal to cosine squared. So I could have just directly changed this one, changed it to cosine squared and have been done. All right, I did an extra step. But in either way, you would have been done. You either would have cosine squared equals cosine squared, or 1 equals 1 is also good as well. The main thing is you're trying to prove that the identity that they give you is true. And you do that by working with both sides until they're equal to each other. Let's look at number 8. Number 8 is easier. With this one, again, I'm noticing that I have a sine, I got a cosine, I have a cotangent. Well, I'm going to turn that cotangent into sine and cosine. So sine times, and I get cosine theta over sine theta, just as I did before, equals cosine theta. Well, this one's pretty easy, because what happens here? Cancel, cancel, and done. Easy peasy. Okay, so now let's look at the simplify ones. Starting with number 17, simplify each trigonomic expression. That just means you need to get it down to as few as terms as possible. Okay, so for example, number 17 right here, 1 minus cosine squared of theta. I talked about this one already, but if you look up your Pythagorean identity, well, what is 1 minus cosine equal to? If I look at this guy right here, again, if I move that cosine squared to the right-hand side, what would I have? I would have 1 minus cosine squared. And what would be left? Sine squared. So that's literally all you need to do. Just manipulate that identity. And done. Okay, that's all that's required there. Just recognizing this identity. Okay, you're allowed to manipulate these identities to get the result you want, as long as it's algebraically correct. Let's look at 24. A little bit more going on here, but not too bad. So again, tip, turn everything to sine and cosine. All right, as long as there's not a square. Okay, square. If you see a square, that means use a Pythagorean identity usually. Okay, but now in this case, no squares. But I do see a secant there. What's secant equal to? Oh, okay. Oh, here we go. So this one is written directly in your textbook, but I do have this one here. Cosine is equal to 1 over secant squared. So if you just flip things around, this is also true. That means secant of theta is equal to 1 over cosine. All right, this one is directly in your book. I didn't write them all in your book, write them all here from your book, but I wrote all the main ones, and you can manipulate any of these to get what you want. So, okay, secant theta is equal to 1 over cosine of theta. All right, so I'll do that. So that's 1 over cosine. Oh, then you have cosine. That's convenient. And sine of theta. Well, what happens? Well, cancel, cancel. And what you're left with is sine of theta. Okay, guys. And that's it, really. It takes some practice to get used to these. Basically, they're just solving like a little puzzle, and with the verify ones, like the first two I did, you want to get the two sides equal to each other using those above identities. The simplify ones, you want to get it down to as few terms as possible, but you're using the same identities that we used before. Okay, it does take some practice. It takes some time to get used to it. Once you get it down, though, usually it's not too bad. Let me know if you have any questions. Okay, thanks, guys. Have a great day.